I am Jvn Dr Srivastava from the Department of Science under the Faculty of Education and Methodology, Jyoti vidyapeeth, University, Jaipur. Today I will discuss about the Banach fixed point theorem. A fixed point of a mapping T is such that x tends to x of a set x into self is an x belongs to x which is mapped onto itself is kept fixed by T such that Tx is equal to x. The image Tx coincides with x. Banach fixed point theorem or contraction theorem. Consider a metric space x is equal to x comma d where x is not a empty. Suppose that x is complete and let T such that x tends to x be contraction on x, then T has precisely one fixed point. Now the proof, first we construct a sequence xn and so that it is Cauchy, so that it is convergent in the complete space x and then we prove that its limit x is a fixed point of T and T has the no further fixed point. This is the idea of the proof. This is the idea of the proof. We choose any point x0 belongs to x and define the interactive sequence xn by x0 comma x1 is equal to t x0 comma x2 is equal to t x1 is equal to t square x0 and so on tn is equal to t to the power n x0. Clearly this is the sequence of the image of x0 under repeated application of t. We show that sequence xn is Cauchy. Then dxm plus 1 comma xm is equal to dtxm comma txm minus 1 is less or equal to alpha d xm comma xm minus 1 is equal to alpha d txm minus 1 comma txm minus 2 less or equal to alpha square t xm minus 1 comma xm minus 2 less or equal to alpha to the power m t of x1 comma x0. Hence, by the triangle inequality for the formula for the sum of the geometric progression, we obtain for n is greater than m, dxm comma xn is less or equal to d xn comma xn plus 1 plus d xn plus 1 comma xn plus 2 and so on d xn minus 1 comma xn. This is less or equal to alpha to the power m plus alpha to the power m plus 2 plus alpha to the power n plus 2 and so on plus alpha to the power n minus 1 dx0 comma x1. So sequence xm converges as xm tends to x. Now we have to show this limit x is the fixed point of the mapping T. From the triangle inequality dx comma tx is less or equal to dx comma xn plus dxm comma tx. This is less or equal to dx comma xn plus alpha d xm comma x. Since xm tends to x, we conclude that d of x comma tx is equal to 0. That implies x is equal to tx. This shows that x is the fixed point of T. Thank you.